All right. Hello and welcome. You've taken the first step, and for that, I congratulate you for wanting to upskill yourself. Tech is wide and daunting, and I think that is what makes it a little bit confusing and complex. But before we get any further, let me allow me to introduce myself. My name is Moses Mbadi, and I think probably 5 years ago, I was exactly where most of you are right now. The only thing I knew about computers was to burn movies on discs and USB flash drives and to download movies. I didn't know anything about coding or software engineering at that time. I remember I was working up to 7 p.m. In the evening. I would go home and watch countless YouTube tutorials trying to learn how to code. Um, of course, it was confusing because first I did not have a guide, so I kept jumping from topic to topic. I didn't know whether I should do backend engineering, front end engineering, whether I should do mobile development. So there was that confusion at first, but I slowly found my footing and I settled on what I wanted to do. So the purpose of this course is to guide you through learning software engineering from zero knowledge. I'm assuming the students who are in this class have zero knowledge in computer science or software engineering. So we are starting from zero. Uh, However, the assumption is you have a computer, you've worked with a computer before, you know how to switch it on, you know how to copy files and whatnot. Um, so the first class, this first class is for beginners. Let me just send my YouTube here. Okay. So welcome again. We're going to cut through the noise. And in this course, we'll focus on only what you need to get you started to develop applications. We will go from zero to, we will come up with an application or a platform, we will build it, and then we'll deploy it. Towards the very end, we can divide ourselves into groups, and we can build our own individual applications in those groups, and then we can launch those applications. Who knows, maybe we can launch the next big thing in Africa. um, yeah. So conventional education is flawed and works on so many assumptions. This is all because they rely on rote memorization. If you remember when you're in school, your teacher only cared about you passing exams and excelling in those exams. That is all that mattered, which made it super confusing and not really confusing, but they missed on the very important skills that you need for the actual job market. And that is what we are going to that is what you're going to fix today. I think the live is displaying something totally different. I do not know why. So let me just, okay. I think it's working okay now. So for example, if I want to teach you software engineering and I start by explaining and I start by mentioning servers and cloud computing and whatnot, it becomes very confusing for you to get what I'm saying. So we need to, for a total beginner, we need to build a mental map, of how digital information moves before writing a single line of code. Um, so what will you cover in this course? We'll go from the basics. That means a blank code editor to deployed application. Uh, what tools will you need? You'll need a programming laptop. I'll explain what a programming laptop is in a minute. You need good internet and you need coffee. Lots of coffee. I've just done drinking mine, so. um, All right, so who can attend this course? If you're very hungry to upskill yourself, if you have that deep desire to, learn something new this year and upskill yourself, then definitely this course is for you. I'm just reading a comment here. I'm trying to multitask because there's only one person here. um, The screen is blurry. Is anybody else experiencing that issue? You can just text on Discord. I will get it. Um, all right, I'm loud and clear. Thank you, Kevin, from Discord. So, if you're very hungry, you want to upskill yourself, this course is for you. Now, what do I mean by that? This is the 8 hours challenge. That means we are going to spend 8 hours every week to learn software engineering. However, the 8 hours are guided 8 hours. That means it's the hours I'm going to take you through. You need to add an extra 2, 3, or 4 hours to get the most out of this course. So here's how our classes will be structured. We will have sessions on Monday from 8 p.m. to 10 p.m. We will have sessions on Wednesday from 8 p.m. to 10 p.m. If I'm going too fast and you're trying to write some notes, you can just let me know. We will have Saturday session from 9 a.m. to 11 a.m. We will have Sunday sessions from 2 p.m. to 4:30 p.m. So you please note that down. Monday is from 8 p.m. to 10 p.m. Wednesday is from 8 p.m. to 10 p.m. Saturday is from 9 a.m. to 11 a.m. Sunday is from 2 p.m. to 4:30 p.m. Now that is a total of 8 hours. But remember, I've told you if you want to make the most out of this course, you want to put aside 3 more hours to the 8 hours, making it a total of 10 to 11 hours every week. Aside from the normal class hours, we are going to have what we call office hours. Office hours will be weekdays from 1:30 p.m. to 2:20 p.m. We'll also have office hours on Sundays from 8 p.m. to 10 p.m. Now, the purpose of the office hours is if you are in a class, like for example, this class, and I explained something or I took you guys through something that you did not understand, you note it down. If I mention something like a function, and you don't know what a function is, but I was too fast for you to get what a function is, you can just write it down, functions, and then you take advantage of the office hours to have me explain what a function is in greater detail. Um, so that's it on the time. I hope everybody has understood the timing. The course is free as mentioned. However, if you feel like supporting the work, I will leave a link to how you can donate. You can buy me coffee. Let's not use the word donate. Let's use buy me coffee. So I'll leave the link on how you can buy me coffee on Discord. You can just click and go ahead. And to keep the course going, because a lot of resources have gone into making this course, we will be doing weekly sort of like donations. So you can feel free to donate whatever you have on a weekly basis with the targets that we'll have. I think we are now live on YouTube. Let me just read here. Yeah, so somebody has asked me to clarify on the hours. So again, I repeat, we have sessions on Mondays and Wednesdays from 8 p.m. to 10 p.m. We have sessions on Saturday from 9 a.m. to 11 a.m. And we have sessions on Sundays from 2 p.m. to 4:30 p.m. So that means the Friday session today was not supposed to happen today, but I had to have it today so that we can really get those who are hungry. And then we will also have office hours. Office hours are on weekdays from 1:30 to 2:20 p.m. Office hours on Sundays will be from 8 p.m. to 10 p.m. Those are office hours. I hope that is well understood for whoever asked me to clarify on the timing. So I think that's it for the introduction, and we'll just jump straight into the business of the day. And I want to do a trick here. I want to. So The computer I'm using is a Windows computer. There is Ubuntu, there is macOS, and we'll discuss about all this as we go on. But I'm assuming most of you are using Windows, so we'll just use Windows for now. But as we continue, we'll learn about other operating systems as well. Let me just close these. If you do have any questions, you can post in the Discord server. If you're not on Discord, I probably have to share the Discord link when I'm done. Yeah, office hours, I think somebody has clarified. So I'm going to open a note here on my Windows, and to open a note, I can just right click and say new, and then I'll say text document, and then we'll call it anything. We'll just say 8 hours. Now inside the text document, I'm going to paste in some text. Let me just format the text. Oh my goodness. Okay, I think we'll leave it up to there. Yeah, the class has officially started. I hope you're following. So let me just zoom in a little bit for those who are using mobile phones. I think up to that point, I can just do that. I think you can just work with that for now. Let me just delete everything else. Now, on the screen, we have a piece of text. It reads, once upon a time, a curious little monkey named Kito found a shiny mirror in the forest and thought he had discovered another monkey who copied every move he made. This is what we call natural language. Natural language is language used by human beings. Other examples of natural languages are Kiswahili, Igbo, what other? I've forgotten, Luganda. Any language that humans use to communicate with each other is called natural language, okay? And that is why it's so easy for us to understand, because it contains characters that we can understand. Now, let me confuse you a little bit with another piece of text here. Let me just copy it. So we are going to copy this piece of text and we'll paste it down here. Okay, let me zoom out a little bit. Let me just see a comment here. So we've said that this is natural language that human beings use to communicate, and therefore we understand each other correctly. Now there's another piece of text I've pasted here, which looks very confusing. But I want you to just try and read through and see if you can pick out any interesting bits. Sorry, not interesting, but any repeated parts of the text. So here we have the diff keyword. We don't know what diff means. Diff might mean define, it might mean definitely. And then we also have get, db configs. So we understand get is, get something, like on something or something. And then we have db here, we don't know what that is. We have configs. So when we read configs, we can say it could mean configurations, or it could mean just configs. And then we have brackets here. We have a list here, and then we have dict. We don't know what dict is. It could mean dictionary, it could mean dictator, it could mean a whole sort of things. And then we have row here. We have OS dot, and then we have get env. And as I'm reading, already your mind is, is on hyper mode, trying to understand, okay, what exactly is happening on the screen. But what I want you to pay attention to is patterns. For example, we have these brackets here. We have these square brackets again here, but here the square brackets have something inside, but here they do not have anything inside. If we read through, we can see we have brackets here, there's something inside, and then there's also something interesting that is repeated, and that is this dot here, and there's another dot here. So words are sort of chained together using the dot. Also pay attention to that. What else is repeated? Could you identify anything else that is repeated? If we read through, we can also see the repetition of the equal sign. In mathematics, remember, equal sign is 1 plus 1 equals to 2. So we can see equal sign is repeated here. If we scroll down, we can see it's also repeated here. And if we keep scrolling down, we can see other forms of repetition of what we've already talked about, like the brackets here and the brackets here. So believe it or not, this is a combination of language that the computer understands and language that the humans understand. And that bridge is what we call a programming language. For those who have looked at programming languages before, you'll realize that this is the programming language called Python. But that is not important. I just wanted to draw that distinction that what we have here is what we call natural language, and this is a programming language. Programming language is a language we use which sort of has some little bits of the natural language, but it also has some little bit of a language that the computers understand, and we'll get to that in a second. So the whole business of software engineering is using technology to solve problems. Now, these problems in the software engineering world, we call these problems features. Let's look at a few features here. I'm just going to copy this. So for example, you have a banking app. What can you do with a banking app? You can log in with your username, password. You can check your balance on the banking app. You can request a withdrawal. The bank will approve the withdrawal, and the money will be sent to your mobile money if you're using mobile money, for example. I'll just take a second here to see if anybody is stuck. Okay, Alco, you're looking for the course outline. I will send that in the Discord channel when I'm done. Anybody else stuck? Let's have a look at. Esther, I don't know why you're not able to access the live stream. You can just go to YouTube and search. You can just go to YouTube and search Moses Mbadi, and then go to the live tab. You'll see this live session. Thank you very much for all those who are trying to help me in the chats. I see Boniface, you're really being helpful. Thank you. And Tracy, thank you. So back to the features. If you look, for example, at commenting on a video on YouTube, first you have to log in on YouTube. You cannot comment if you're not logged in. Okay, you can watch the video, but you cannot like or comment on the video if you're not logged in. So what do? You log in on YouTube, you open a video, you click on the comments box, and then you type the comment, you hit send. How about booking a flight? What are the steps involved? Number one, you search the flights that you want to book. You sign into the platform that you want to book the flight, and then you pick a seat. Thank you very much, Jess. And then you pick a seat, pay for the ticket, and then you get the ticket sent to your email. So These are features. They are what we do on a daily basis, and you can think about any feature that you're using. Um, So, for example, if you're on Discord and you type a message, so you have to be logged in on Discord. You cannot type a message if you're not logged in. So, the first step is you log in, you open the channel that you want to type your message, you type the message, and then you click send. And then the message goes to whoever you want to send a message. So, these are what you call problems. In the engineering world, we call them problems, but in the human world, we call them, okay, we are both, it's both the human world, but we call them features. So, what am I trying to prove here? Software engineering and the whole business of computer science is understanding problems and crafting solutions for those problems. So it's very important you start with a problem and then break it down into smaller problems that you can solve and fix those smaller problems. Before coding, you need to understand what a computer is and the environment that you'll be working on. And that is what we'll discuss next. So, of course, I've typed all this, I've opened Notepad, but we need to understand the environment you're working inside so that we understand how best to solve problems. Um, yeah, so let me take a break, let me take a glass of water, and I'll be back. All right, and we are back. Let me see if somebody is stuck. Um, uh Doing what exactly? I don't understand. Tan Francis, I didn't get your issue. So we need to define what a computer is. A computer is more than just a laptop. It A computer is essentially a system that takes user instructions, it processes those instructions into information. Computers come in all forms and sizes. Like, for example, we have the tiny computer inside your microwave. We have a computer inside your refrigerator. We have the computers that are inside our cars. We have computers that digital watches. Computers. Computers come in all forms and sizes. But the core concept is a computer is any electronic device that takes instructions, it works on those instructions, and it gives you information or an output. That is what a computer is. When you look at your laptop, for example, you have the hardware bit. For example, if you look at your phone, you have the hardware bit, and then you have the software running inside your computer on your computer. So most computers are made up of two parts, hardware and software. Hardware is the physical body, of course, like I've clarified, and software is whatever is working inside that hardware. Of course, neither can function without the other. You cannot have a software without the hardware. For example, part of your hardware is your keyboard. And part of your software is what you call the operating system. An operating system is basically what controls the hardware and it gives instructions to the operating system. So, for example, if you do hit a key on your keyboard, this is a hardware. You are trying to say, I want to hit the X key. So the operating system is what is responsible for taking that instruction, the X key, and then transmitting that information to whatever editor you're using to type. So for example, here, if I type, for example, Moses, if I type, for example, Moses, the name Moses is written on the screen, but there's a lot that has happened between me typing on the keyboard and the information appearing on my screen. So what happens is when you hit anything, like for example, when you press the volume up button on your phone, you are interacting with the hardware. but somehow you'll see the icon on your phone changing the volume. So that means your software has gotten the instruction to turn up the volume. Now, whatever is responsible for transmitting that message between, a good example is if you're watching this video on YouTube and you want to turn up the volume. So what do? You press the volume up button, and then on YouTube, you'll see the volume increasing. So operating system is what is responsible, it's responsible for taking instructions from the hardware and transmitting those instructions into whatever you see on the screen. Of course, an operating system does a lot of things, but that is what we can just describe it as for now. Um, so what makes up a computer? We've talked about the hardware and the software. The software is what is running inside your computer. But apart from that, any computer is made up of a CPU, memory, and storage. So a storage is something that looks like this. Let's just so a storage is something that looks like this, a hard drive. And we also want to look at RAM, and we also want to look at CPU. So a storage is something that looks like this. If you've ever tried to repair your computer, maybe the hard drive died and you wanted to replace it, you saw something that looks like this, which you bought and fixed it on your computer. So this is the storage. Now, this is what you call a permanent storage. But RAM looks like something like oh, okay. So there's a track like this called RAM. Okay, that's interesting. Oh, okay. So a RAM looks like this. It's what you call, some people call it a memory stick. So these and these are both forms of storage. However, one of them is called, one of them stores information permanently, and the other one stores information temporarily. And I will draw a diagram here that explains that in more detail so that you don't get confused. So let me try to get my drawing tool here. So we've said a computer is made up of different parts. So you just put the CPU here. We'll get the text. Oh no, my connection disappeared. Let me get back my connection. So I'm going to use a different tool. Let me just use this here. So do tell me if you can see my screen. It should be black. So I do have a storage here for those who have not seen it. This is what you call an SSD. It's a hard drive, but it's type of hard drive called an SSD, which is a little bit faster than other ones called HDD. So we'll continue. All right. So we do have, for some reason, let me just see. All right, my drawing tool was misbehaving. I don't know why. Okay, interesting. Let me just try to restart this. Oh, that's taking ages to load. Let's just use any disk again. Okay. Yeah, so we have RAM. We have HDD, or we could just say hard drive. And then we have the CPU and the CPU. So I'll just try to enlarge this for those using their mobile phones. Let me see if I can do that. Not that. Please text. Need to increase that. Okay. All right. All right, let me take a second to see if anybody. Okay, so I don't know where the arrow come from. Okay, cool. So as a software engineer, it's very important you understand how these three work together to to make your instructions well understood by the computer. Of course, I'm using different words to explain what that means. But let's take an example. The screen is too bright. Please make darken the background. Okay. Okay. I'll try to do that. So let's look at let's say let's look at a Word document. I'm assuming most of you have used a Word document to type, your resume, your CV and whatnot. So when your computer is off, your Word document is inside what we call the hard drive. So let's say this is a resume. Okay, so when your computer is off, your resume is inside the hard drive. When you power on your computer and you want to edit your resume, what will happen is the resume will first get loaded into the RAM, and then the CPU will pick it, and then now you can send your instruction to the CPU. So what does this tell us? Number one, the CPU is what will process your instructions. So you don't send your instructions to the RAM, you don't send your instructions to the hard drive, you send your instruction to the CPU. But the CPU does not have the capacity to store information. So it uses what we call a temporary storage to store whatever it is you're doing. So if you're typing a Word document on your computer, your Word document is inside the RAM, but it's being read and written to using the CPU. So you send your instruction to the CPU. The CPU will read it from RAM, and then it will, if you're adding information, it will add information to your resume. Now, imagine you shut down your computer while you have not saved your work. Your resume will go. Okay, previous changes will remain, but any changes that you've made will not be present. And that is why if your computer goes off while you are editing a document, all the changes that you've made, if you did not save those changes, you will not get those changes. They are gone. That is because the RAM and the CPU all go dead when your computer is, okay, not really dead, but they go inactive when your computer is off. When you shut down your computer, they both go empty. So that is the difference between a hard drive and RAM. These two are both storage media, but they store information at different stages and they store information differently. Everything builds on top of that. Every computer that you can think of, your smartwatch, the computer inside your fridge, the computer inside your microwave or your TV, they both have a CPU, they both have RAM, and they both have a hard drive. Even your phone has a hard drive. When you go to buy your phone, you're told, hey, it has 32 GB storage and 2 GB RAM, and whatever. So every computer, just keep in mind that every computer has a CPU, it has RAM, and it has a hard drive. I hope that is well understood and I'm not confusing anybody. Actual size. So this is what a hard drive looks like. This is what we call SATA hard drive because it takes the SATA cable, and this is what we call an NVMe because it does not really have a cable. You just plug it into your motherboard. And I wanted to show you an example of how a CPU looks like. Image 2, what do you mean resize? Okay, so this is how a CPU looks like. If you open your desktop or if you open your laptop, you'll see something that looks like this. It has the words, if you're using most brands of HP laptops, Lenovo and whatnot, it has this thing written on it, Intel Core i something. That is what we call the CPU. So let me also show you what a RAM looks like. I'll just paste it here. This is what a RAM looks like. So if you've noticed, a RAM looks sort of like similar to an NVMe storage, as you can see here, but they are both different. RAM will have these ends inserted into the motherboard, and NVMe will have these ends inserted into the motherboard sideways. The RAM goes like this. So while talking about CPU, RAM, and hard drive, we also need to identify, because sometimes when you go to buy a laptop, you're told this laptop has 16 GB of RAM, this laptop has 18 GB of RAM, and you're wondering, okay, so what is the difference? So assuming you have a couple of applications, and we'll just list them here. You have Chrome browser, the one used to watch YouTube and whatnot. You have VLC player. You have TikTok. What else can you have? You have what other tools? Oh my goodness. For example, you have Need for Speed, a game. Okay, so I'm trying to, let's change the alignment. Okay. So if you have all these things open on your computer, the same way I have all these open here, I have this tool, this tool, this tool, this tool, they are all open. Keep in mind that they will all be present inside the RAM. Okay, so the one you're working with, the one that is active is what is inside your RAM, and it's what is inside your CPU. So for example, if you have RAM, let's say 2 GB, or let's say 8 GB, okay, and each of these applications require, let's say, 4 GB to run, and we'll look at what that requirement is. If each of these applications require 4 GB to run, that means your RAM will be overwhelmed because you're working with 4 times 4, that is 16, when your computer has 18 GB of RAM. So your computer will try to struggle because the CPU is struggling to communicate with RAM since RAM is overwhelmed. And that is why you'll feel sometimes your computer is making a lot of noise. The fan is running a little bit louder, and you'll also feel it's overheating. That's because both the CPU and the RAM are working overnight. Sorry, not overnight, but beyond their threshold. Yeah, Drexler, the video will remain on YouTube for you to view it later. So we've spent quite a lot of time on RAM and CPU, and now let's move on to other topics. So let's look at how the computer sees and understands your file. Now, to a computer, everything is a file. The computer only understands a file. So, for example, this right here is a file to the computer. This right here is a file to the computer. However, if you've noticed, this right here has a different sort of like characters after the dot. This one has .exe, this one has .txt, and this one has .cmd. They are different file formats. We call them file formats, but they all are files to the computer. So if you look at also something like, if we download an image, do we have an image here? Let me see if we have an image here, downloads. So let's just download an image. Let's download this one, save image. We're going to save it under downloads. We'll also download another one. Let's go to this, save image. Under downloads, we'll download it. So as you can see, we've downloaded two images, but if you pay close attention, they have different formats. This one ends with a .webp, this one ends with a .png, this one ends with a .exe, this one ends with a .dll. Now it's important you understand these extensions, because when we come to writing the actual code, we will use this type of extensions. We call them extensions, the dot something, to explain what the language is inside a particular file. So for example here, if I do want to create a text document, I will just right click, I say new, and then I'll say a text document, and then I'll say sample text document, and I hit enter. So as you can see, it's called sample text document is what we have typed, but the computer has appended something called .txt. This .txt is what tells you what is inside that file, or what that file does exactly. So this is also important to understand, because if you have your own laptop and you don't understand what the extension of a file is, you might end up running something on your computer that you did not intend to run. And that is why we have things like ransomware, where you run an application on your computer, and then it takes all the files and locks them until you pay the hacker or whoever some money. So before you open any file on your computer, it's always very important you check what type of a file it is. So in some cases, you will not see this .exe here. For example, I can just rename this file and I delete this .exe like that. So as you can see, it does not have an extension. So we do not know what this file is, what it does. So instead of running the file, yet you don't know what it is, you can just right click on it. I hope you all know what right clicking is. You can just right click on it, and then you go to properties. And then under properties, you can see it's right here, type of file, it's a Windows installer. So a Windows installer means it's installing something on your computer. We can do the same with an image. For example, here I can rename this file. I can rename it like so. And then as you can see, we do not know what type of a file this is. So we can just right click on it. We go to properties. And then right here, we can see type of file, it's a file. Okay, so the computer is a little bit confused because it's an image, and images require an extension to identify them as an image. Now, I can also pick an image and give it a false file format. So this one, for example, it was an image. If I just go back, as you can see, it's an image. I can open it as an image, like so. But I can also right click on it, rename it, and then instead of calling it an image, I will call it a PDF. And then I hit enter. So as you can see, it's appearing as a PDF, but it's not actually a PDF, it's an image. So those are some of the tricky ways hackers and malicious actors use to trick you into running things on your computer. Now, the title of this course was a self-taught computer science. So we are not only going to focus on software engineering, we're also going to touch some little bit of cybersecurity and everything else in between. So that's it on files, unless there is any other questions. All right. So apart from files, what else is also important for you to understand as a software engineer? It's also important for you to understand the size of how, okay, in short, how we measure digital data. So anything on your computer is a file, like I said, and it can be also referred to as a digital data. So how do we measure the size? If I come to my folder here, I can see there's a size column. So let me just drag it to this side so that it becomes easy to know. So on your end, this column might be on this side, but I've just dragged mine to this side so that we have a good look at them. Let me just zoom in. Oh no, I have made a mistake. Let me just zoom out first. Okay, so this sample text.doc, as you can see, it's 0 kilobytes. This KB here, it means kilobytes. This PDF file, this false PDF file is 488 kilobytes. If we go to something like this .zip, it's 8,843 kilobytes. So kilobytes is like the smallest unit of measurement, which means this thing is very light. It's very light. Even if you try to copy it to another folder, it will take very little amount of time to copy. If you go to a folder like this, and I'm trying to find something a little bit heavier, or let me just do this for now, or I can go here. Okay, so if you look at a file like this, as you can see, it's saying it's 1,562 kilobytes. So that's quite big, and it can be very tricky to understand. But that is how the computer is set. It only shows you information in kilobytes. Let's try to see the properties. So if you right click on it and go to properties, you can see this file is 1.48 gigabytes. Gigabyte is like really big, but it's not the maximum we have. From gigabytes, we have what we call terabytes. And that's why when you go to buy a hard drive, for example, this hard drive, let's see. So if you can see here, this hard drive is written 256 gigabytes. So that means it can store 256 gigabytes of storage inside it. So that is how we measure sizes in the digital world. So why is this important? When you're writing code, when you're creating applications, it's important to understand what the size of your application is, okay? If you write something that contains a lot of junk, a lot of data inside, and then it becomes very big, it will become cumbersome for people to install your application or to use your application. So you have to make your applications very light so that it becomes easy for people to install and use. Yeah, so let me read some comments here. Hi, Robert. Yes, the recording will stay on YouTube, so you can just come back to it later and watch it. Yeah, so that is it on storage. We've looked at how computers measure storage. They measure storage in kilobytes or gigabytes. They also measure storage in megabytes. In your computer, for example, you might see MBs instead of gigabytes or kilobytes. So if we open this file, for example, and we go to properties, as you can see, it's saying it's 125 megabytes. But here it was telling you it's 127,000 kilobytes. So the conversion here is 1,000 kilobytes make 1 megabyte. It's like kilograms and grams. For those who use kilograms and grams, 1,000 grams make 1 kilogram. Is that correct? I think it is. I hope it is. So here also, if you get like 127,000 kilobytes, that will directly translate to 124 megabytes, and so on and so forth. So we have gigabytes, megabytes, terabytes, and all that. More you'll understand as we continue to learn. So that's it on storage, unless anybody is stuck or there's any questions. All right, so let's dive deeper into the forms of computers, and you can just try and, from the explanation I'll give, you can try and think about the computers in your house right now and put them under any category. So number one, we have what we call embedded chips. An embedded chip is just a very small something like a motherboard, if you know what a motherboard is. And I think we can just come here and Google what an embedded chip is. Embedded chip. All right, so these are all examples of embedded chips. It's just like a chip, a normal computer chip that is embedded into another piece of hardware. So if we look at a microwave, for example, I've been using this microwave example for a very long time. I think I'm hungry. Anyway, if you look at a microwave, you do not get like a screen. Okay, for most motherboards, you do not like get a screen. You don't get a keyboard. If you get a screen, you just get something to touch on. It has an example of an embedded chip. If you're using an electricity meter, the one that you put in your tokens and then it tops up your electricity, it has what you call an embedded chip. An example of an embedded chip is if you're using a what? If you're using some form of light, for example, if you have a ring light, if you have maybe let's say an LED light, you only have buttons. You can click, say, hey, I want green light, I want blue light, or make this brightness a little bit less or a little bit more. It has embedded chip inside. So you can think of an embedded chip, just something like an electronic device that has the CPU, the RAM, and storage all in one. For example, if we look at this, it's an embedded chip because it has everything in one. It has the CPU, the RAM, and storage inside it. And that's what makes it an embedded chip. So another example is like a smart thermostat, like your router, your Wi-Fi router. Of course, it works. You see the lights blinking, but you don't see any display. You don't get any keyboard to type, but it's a computer and it has an embedded chip inside. Apart from embedded chips, we have what we call personal computers. And I think you can guess what a personal computer is. It's your laptop, what you're using right now. It's your computer, it's your phone. That's what we call a personal computer. Another example is a personal computer is like, I've said your phone, yeah? Your phone, your laptop, your desktop. Yeah, those are examples of personal computers. Now, when we move away from embedded chips and personal computers, how does the entire landscape fit into one? Now, this is where we have what you call the internet, and we'll just have a look at how the internet works here. Let me just get my drawing tool. We'll move this out of the way. So right here, you have your laptop. Let's say, for example, Peter's laptop, okay? Peter's laptop. So Peter's laptop has Chrome browser, it has VLC, it has TikTok, it has Need for Speed games. But Peter is inside his home. Let me just reduce the size of this. What am I doing? Okay. So Peter has a laptop, of course, but Peter is inside his house. And let's just, I want to back. So Peter is inside his house. Now, Peter inside his house in, let's say, for example, Nigeria. Let's say this is Nigeria. Oh, by the way, I'm explaining how the internet works, so pay close attention. So Peter is inside his house. He has his laptop, and we have Moses. Moses is over here in Kenya, and Moses has his laptop. Okay, and inside Moses' laptop, we have draw.io, the tool I'm using right now to draw. We have Mozilla browser. We have AnyDesk. We have YouTube, whatever I'm using to stream, okay? Now Moses is inside his house in Kenya. But Peter in Uganda or Nigeria is able to see the content Moses is posting on YouTube. Now, how does that happen? Moses inside his house has a router right here on my wall. Okay, it's literally on my wall. So Moses has a router right here. So you can say a Wi-Fi router or just a router. Now, also Peter, what happened to Peter's router? Why is it not visible? My goodness. Okay, I have to bring it to front. All right. So Peter also has a router. Now remember, Peter's computer cannot do anything, cannot watch YouTube videos if the router is off. If the router is off, Peter cannot watch YouTube videos. Also, Moses cannot be able to continue with the live stream if the router is off. I'll just put a link here. This is just like an invisible link connecting the router and my laptop. But these two routers need a way to communicate to each other because Peter here will ask the router, hey, there is somebody called Moses in Kenya. He has a YouTube live teaching software engineering. I want you to go and bring me the content he's uploading. And this router will somehow find a way to get the content Moses is uploading. And that is where the internet comes in. You can think of the internet as just a giant interconnection of computers, and I'll explain you how in a minute. So somewhere in the cloud, we will look at what the cloud is in a second, but just bear with me. Somewhere in the cloud, we have what we call internet service provider. If you're in Uganda, we have MTN. If you're in Kenya, we have Safaricom. If you're in South Africa, we have Vodafone, I think. If you're in Nigeria, I don't know what they use. But we have what we call internet service providers. So, my goodness, why are you not behaving? Okay, we'll just work with that. Let me move this. Oh my goodness. Let me move this. So what this router will do, this router will communicate with the internet service provider. The internet service provider will then check what request are you sending. Oh, this person is asking, I want to get the content belonging to Moses Mbadi on YouTube. Now the internet service provider will be responsible of getting that content from the router that is connected to Moses, like so. And this is basically how the internet works. But we do not only have your internet service provider in the mix. There is, of course, other players, like, for example, you've heard of AWS, you've heard of Microsoft and all that, and Facebook and all that. And we'll look at cloud computing and we'll dive deeper into that. But what am I trying to paint here? Number one, digital information flows. So the whole concept of software engineering is understanding how the digital information flows and how we can make it flow better and flow secure. So for example, here, Peter will say, hey, there's a guy called Moses from Kenya. He's teaching software engineering on YouTube. Get me his content. This router will go to the internet through your service provider and say, hey, I want Moses on YouTube. I want his content. And Peter is asking for that content. So of course, the internet service provider will go to Moses' router, get the information, and then transmit it back to Peter's laptop. So digital information has to flow. Okay, let's see if somebody is stuck. Okay, nobody is stuck. Thank you, Stephen, for the check-in. So yeah, this is not the accurate. This is not, it's a highly, what can we say? Um, it's highly minimized. Is that the word? Yeah, it's a brief intro of how the information flows in the internet. So just keep that in mind. We have embedded chips, we have personal computers, we have the internet, which is just a giant interconnection of computers. And if you really think about it, different computers speak to each other. Right here, I might be using a desktop. Peter might be using a mobile phone. The router, of course, is using an embedded chip. The internet service provider might also be using an embedded chip or other forms of computers. We'll look at them in a second, but they will all communicate with each other. Um, all right. Let me just check if I have any questions. All right. So we will end here for this lesson, but just a recap of what we've done. We've looked at what a computer is, and we've said a computer is any electronic device that takes instructions, it processes the instructions, and then it gives you an output or information. We've also looked at the types of computers. We've said we have embedded chips. Those are very tiny computers inside your, devices like your microwave and whatnot. We've also looked at how the digital information flows. Somebody will make a request, hey, I want the content for this person, and then the internet service provider will go get you that content and deliver that content to you. We've also looked at parts of a computer. We've said any computer will have a CPU, it will have a RAM, and it will have a permanent form of storage. We've said we have HDD, which is a hard drive. We have RAM, which is a temporary form of storage, and we have the CPU. So I think we'll end it for this session here. We did have a little bit of a technical challenge early on, but I think everybody has gotten me loud and clear. So we'll end it for today. The next session is tomorrow from 9 a.m. and it will be a very complex and heavy topic. We will now dive deeper into what is software engineering, what we mean by coding. When you say we are writing code, what does that mean? We look at the terminal. What is the terminal? Or some people say command center. We'll also look at setting up our computer for software engineering, what tools we'll need to set up, to download and install, and all that. Yep. I think I don't have any other questions. All right, so if you have any questions, you can just post them on Discord, and then I'll get back to just checking if I have any questions. Yeah, I think that's it for this one. I'll see you guys tomorrow from 9 a.m. as we dive deeper. Thank you very much for being here.